Alright guys, so today is 7.4, solving exponential equations. Just so you guys know, the assignment is going to be a Hawks assignment. It'll be 5.1, but this is also what you did in 7.1. So it's going to combine 7.1, the graphs, and it's also going to combine what we're doing today. So last class period we looked at some essential properties of logarithms. We'll review some of those properties that will be essential to solving exponential equations. So in logarithms, don't forget the a and the exponent is going to go out front. If they have log base a and the base of the exponential equation is the same thing, it's just going to be x, or vice versa. If it's a base raised to a log base and they're the same, it's just going to be x again. And then natural log and common base e are going to cancel each other out, so it's just x as well. So those are just some helpful things to help you solve exponential equations. So what we do is there's some guidelines for solving exponential equations. You're going to simplify the equation if necessary to get in the form b raised to the x power equals a. Take the log, use common log or natural on both sides, use properties of logarithm to simplify, get x by itself. So when we solve these elementary exponential equations, we're really just trying to get them the same base. So I usually look at the whole number 2 and think, how can I get 32 rewritten as a base of 2? Well, 2 to the x power, if I want to rewrite 32, I got to think 2 to the what power gives me 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So how many 2's do I have? Well, that's 5. So now that they have the same base, I can get rid of my bases and just say x equals 5. And that is you solving that elementary exponential equation. So go ahead and try this one by yourself. All right, we're going to rewrite 16 in terms of base 2. And normally you're going for the smallest base. And based off of if it's a whole number. You're looking for a whole number most of the time. All right, so that's going to be a little bit different. It just kind of depends on the problem. So 2 raised to the power of x minus 4 is equal to, if I rewrite 16, that's 2 to the 4th power. So now I'm going to get rid of my base. I'm going to say x minus 4 equals 4, and then I'm going to solve for x. I'm going to add 4 and say x equals 8. This one, they're 4 and 8, right? I can't really rewrite 8 in terms of base 4, because 4 to the 2nd power is 16. But what I can do is rewrite both of them in terms of 2. So 2 to the 2nd gives me 4, but I still have that 2x minus 1. 2 to the 3rd gives me 8, but I still have that x plus 3. So now when you have an exponent to an exponent, right, you're going to multiply. So I'm going to say 2 to the 4x minus 2 equals 2 to the 3x plus 9. Now they have the same base. I can get rid of it and say 4x minus 2 equals 3x plus 9. And then I'm going to solve it. I'm going to subtract 3x. I'm going to add 2. I'm going to say x equals 11. Next one. All right. Normally what we do is we take 1/2 and we think, can I square it to get to 1/4? And the answer is yes, because you would square the top number and the bottom number. 1 squared is 1, 2 squared is 4. So I'm going to say 1 squared, or 1/2 raised to the 3x plus 4 is equal to 1/2 squared raised to the 5th power, because 1/2 squared is going to give me 4. So these right here I'm going to multiply again. I'm going to say 1/2 to the 3x plus 4 equals 1/2 to the 10th power. So then I have 3x plus 4 equals 10. Subtract 4. Divide by 3. X equals 2. So that's really all this lesson is just solving elementary problems. All right, and a lot of it's just rewriting the base. So next one, it says 32 raised to the negative x equals 2. If I went and solved this, 2 to the 5th power gives me 32, and this would be 2 to the 1st. So now I would say 2 to the negative 5x equals 2 to the 1st. So then negative 5x equals 1 because they have the same base, and then I would divide by negative 5. X equals negative 1/5. All right. 1/9. Well, I know 3 squared is 9, but if I wanted to make it 1/9, I would say 3 to the negative 2nd. So we're going to rewrite this as 3 to the negative 2nd. So 5x minus 4 equals negative 2. And you can always type it into your calculator to make sure you get the right thing back to 1/9. That's how you know you did it correctly. So 5x equals 2 divided by 5, x equals 2/5. So I want you to kind of try these last two. I know this is not an easy process, but think about what am I going to rewrite this in terms of, because it's already base 10. So I would say 10 to the third power raised to the negative x equals 10 to the 8x minus 10. 10 to the negative 3x equals 10 to the 8x minus 10. I can get rid of my bases now because they're the same, and I can solve the problem. So I should get 10 over 11. That's a little bit trickier. Think about how can I rewrite 1/25th? Should be saying to the second right there. Kind of got a little sloppy with my handwriting. So 1/5 to the 5x plus 3 equals 1/5 to the 10th. So now I would have 5x plus 3 equals 10. Subtract 3. We get 7/5. I don't know why I wrote 10 there. This should be a 4. I'm sorry, guys. 4, 1. I must have thought that was a 5 right there. So it's a 2 on the exponent. So let me go back and fix that. So that'd be 2, 4. 4 minus 3 give me 1, so it should be 1/5. There we go. My fault on that. All right, so that's all the whole lesson is just solving elementary equations. If you guys have questions over it, let me know. Your homework is 5.1 Certify. Again, reach out. I'm more than happy to help.